Hi everyone, my name is Karthik. I'm aspiring to become a network engineer. Right now I'm preparing for CCNA and I'm trying to share my learnings through these videos. So before we get into the video, a big shout out to Jeremy's IT Lab. All these notes that I have prepared are based on the Jeremy IT Lab videos, and a big shout out to Dynamips. I'll be showing some of the labs that I bought from them, and those are really useful and really practical, so shout out to them as well. So without any further ado, let's get into the video. So today I just want to discuss about VLAN trunking protocol. So this VLAN trunking protocol VTP, what problem does it solve? So the VLAN trunking protocol solves a major problem, that is simplifying the VLAN management in all the switches. So it allows the VLAN configuration to be synchronized across multiple switches. So that is the main focus of the VTP. And if you could see the schematic, the most important thing that we notice is all the switches uh, which which is capable of using VTP must have trunk ports in it. So this will make it easier for the VTP messages to pass. And if you could see, the VLAN database in every switches are of the same revision number. So we will discuss about the revision numbers in detail. But if you look into the show VLAN brief uh, command, you could see that there are default VLANs already present in them. So these are reserved VLANs, and you can even find these details in the VLAN.dat file. So if we look deep into the VTP messages, there are five features in it. One is the VTP version, domain name, revision number, updater ID, and VLAN info. So even though there are like one or two extra features in the VPT messages, but we would primarily focus on the first three, and the last two, updater ID and VLAN info, are just the information that regarding the sender of the message. So whichever switch sends the VTP message, uh, we record that ID and the VLAN info. So the VLAN info has the information like if it is a server or a transparent, etc. So that also we will discuss uh, in the video later. So if we look into the VTP version, there are three versions in VTP: version 1, 2, and 3. The first version introduces us to the standard VLANs, which is 121.0.0.5, and this will be the default settings in any switch that we first enable them. And then comes the version 2. Version 2 supports the token rings, and also it has introduced us to the concept of transparent switches, which we will look into later in the video. And and the version 3 is the latest version that is used in every modern switches right now, and it introduces us to two main important topics. One is the primary server, and the other one is supporting the extended VLAN ranges. So the ranges are 1006 to 4096. So these are the versions of VPT, and we need, in order to know the importance of the version, we should look into the other two topics as well. So domain is like a club where we share information. So similarly, the switches needs to be in the same domain so that they can share information like the VLAN database, and it is very important that these switches belong to the same domain name. And uh, the switches have the tendency to sync their database with the switches which has the highest revision number. So what is a revision number? Each VLAN database has a revision number, which means the amount of changes that has been done in the VLAN database. All those changes will reflect as a revision number in the VLAN database. So why is it so important? For an example, in a domain, we have a switch, and the database revision number is 5, and it has three VLANs in it, and we suddenly insert another switch with a VLAN database revision of 50, and it has only two switches in it. So what will happen is, as I discussed before, the switches has the tendency to sync the database with the VLAN database of higher revision number. So what will happen is, VLAN 20, which is not present in the VLAN database of revision 50, will be totally erased, and the switch will simply copy that database to its own database. So as you could see, there is a huge data loss issue if we cannot follow the revision numbers properly. And there are some ways to mitigate this, but before we get into that, let us look into this default setting of the VPT. What do we see when we give the command show VPT status? We could see that the revision is basic, just the revision 1, and there is no domain name assigned to it, so it is null. And we could see that the default setting of the switch is server. So every switch has the default setting of server. um, we will look into what is a server, what is a transparent mode, server mode in the next slide. And the configuration revision, as we discussed before, the configuration revision is 2. Usually it is 0. Since I have done some changes in this switch, I am having number 2 in it. Now let us look the most important part in VTP. So in this VTP, the switches can be in 3 modes. One is the server mode, client mode, transparent, and off mode. So all these modes can do certain functions. So primarily we have like 5 functions in it. So the first function is change VLANs. Change VLANs is nothing but modifying the VLAN, deleting or even creating a VLAN, and advertising the database. So when there is a change in the VLAN database, the switch can advertise their changes to the other switches in the same domain. And the other one is receiving the advertisement. So whichever changes has been sent by the neighboring switch, the current switch should be able to receive those advertisements. And the other one is sync with database. So syncing its own database with the database of the highest revision number. That's what we discussed in the revision number concept. So when we receive an advertisement and when the switch decides to sync the database, it will look to the revision number. If it is highest revision number, then it presumes that that is the latest version, and it will start syncing up. And the other one is forward VTP messages. So this is what we have seen in the first slide. So the switch should be able to forward the VTP messages in the same domain. So the servers primarily can do all the functions, and it can change the VLAN, it can advertise, receive the advertisement, sync or forward VTPs. But the client cannot do this function, like changing the VPTs, modifying it or deleting it. Other than that, it can do the other functions. In the transparent mode, a switch can change the VLANs, and it can even forward the VTP messages, but it does not participate in advertising or receiving or syncing up with the other databases. And in off mode, the only thing that we can do is changing the VLANs. Other than that, all these functions are totally disabled. Now coming back to mitigating the revision number problems. So as I said, having a rogue switch entering the domain with high revision number and causing a disaster is something that can be avoided. So the first step, or one of the steps, is you can change the domain name of the switch to null and change it back to the original name. For example, if you have a rogue switch which has a name of Cisco, and you just change it to null, and when you change it to null, you could see the configuration revision remains the same. It's number 2, and you change it back to Cisco, and if you can notice that the configuration revision has changed to 0. So if you decide to insert a switch in a domain, make sure to do this step so that the revision is brought back to 0. And there's another way is the VTP mode transparent. So this, as you could know, as you have seen, it doesn't participate in advertising, receiving, or syncing the databases. So when you pass this command, automatically the revision number changes to 0. So this is also another good way to bring the revision number to 0, and the switch is pretty much safe to insert into that domain. Now finally we will look into the primary server. So version 3 has introduced us to a really important concept, that is the primary servers. So what does these primary servers do? Primary servers are like the typical servers that we discussed before, but the main feature here is primary server has the highest revision number in a domain, and you just have one primary server in a domain, and all the other switches must sync their database with the database of the primary server. So in that kind of a scenario, even if by accident we plug in a switch with high revision number, this is not going to affect the network, because the other switches are not going to consider the database of any other switch other than the primary server. So in that case, even a rogue switch with the highest revision number, even if they enters the domain name, this is not going to cause us any chaos or disaster. So that is one of the major feature of the primary server. And we have another concept called secondary server. This is like a client server. It cannot create or delete the VLANs, but it will take up the position of the primary server if the primary server for any case goes down. So these are the concepts of VTP. I hope you guys um, had some kind of information, and I'm open to any kind of criticism. I mean, I'm just learning the networking concept, so if there is any kind of improvement needed, please let me know. Thank you. So we have discussed the theory part in the previous section. Now we can do some hands-on lab, and as you could see, I have a very simple schematic, and I have the terminals open of every node. What I'm gonna do right now is I'm just gonna change the host number for every device. Okay. Host name R1. Similarly, I'll be changing the host number for all the devices. So once the host names are changed, I'm gonna create the trunk ports for switch 1 and switch 2. Right now I'm in switch 1. I'm gonna select the interface 0 and switch port mode trunk. Oh, we have to change the encapsulation, so it is switch port trunk encapsulation dot 1q, and now switch port mode trunk. Yes, it works now. Then switch to, we select the interface E0/0 and switch port trunk encapsulation dot 1q and switch port mode trunk. Yeah, now we have created the trunk port for both the switches. Now we can create VLANs in both the switches. So I'm gonna create VLAN 10, and I'm gonna give it a name sales. Then I'm gonna create VLAN 20. I'm gonna give a name, say tech, I guess. Okay, now we can create the VTP domain for switch 1. So we can just exit VTP domain, and we can give it a name called Cisco. So we could see the VTP domain name has changed from null to Cisco. Here we want the switch one to be a server, so we know that the switches by default are server, so we are not going to do anything about it. So let's go to switch 2, exit. So we give the same VTP domain Cisco. It has changed from null to Cisco, and we are going to convert the switch from server to client. So VTP mode client. Oh, it's already in I guess I have changed it before. So it's in VTP client mode, and we need to understand that we won't be able to create any VLANs in the client mode, so we will leave it as it is, and then move on to the next part. So here what we are going to do is we will create an access port which will allow the VLAN traffic in switch 1. So let us select the interface E0/1, switch port mode access, and switch port access VLAN 10. Yeah, so we have created an access port which allows the VLAN 10, and similarly we will do that in switch 2. So in switch 2 we select the interface E0/1, and we make it a switch port mode access, and switch port uh, mode VLAN switch port mode VLAN 10. Sorry, switch port access VLAN 10. And yeah, we have created the switch port, and now we are going to configure the routers. We will select the interface E00, and we will assign an IP add 10.0.0.1 255.255.255.240, and no shutdown. Similarly, we are going to configure R2. So we enter the interface E0/0, and we add IP address 10.0.0.3 255.255.255.240, and no shutdown. Yeah, now that we have configured everything, we can just ping and test our configuration. Ping 10.0.0.3. Yeah, so the ping is success and the configurations are correct. So what we can do here is we can try the VTP version 3 command. We can try and change the version of the VTP, and also we can use the VTP mode transparent, so that we can change the revision number of the VLAN databases. I guess I didn't show the VTP status command, so show VTP status. This will give you all the configuration revision, the number of VLANs, the domain name and the version, So we can even change the version, or we can even reset the configuration to 0. If we start changing, adding or removing the VLANs, we might see some increase in the revision number. And yeah, that's pretty much everything. So thank you.